Right. If we talk about today's session, it is simple about linear regression using Python. So how do we relate our statistical term regression to a programming terminology, which is a very well known and very easy to learn programming language, Python. So that's what I would like to clear, how Python is related and how mainly statistical term regression is related to Python. So can anyone, what do you mean by regression? It is how you find out the relationship between, I can say, dependent and independent variables. To me, to be more correct in a layman terms, you find out the relationship between dependent variable and independent variable. Right? So that is basically a term which is from statistics, right? So then how does that is related to machine learning, the term which has been emerged in 21st century, and how does that has been related? I'll give you that clarity and then we'll go for it. Because first thing, when we talk about statistics, it is something like how you describe your data, right? So it is how you describe your data and you find how you find out the relationship. Generally, if I talk about data, that can be of two types. You can have general any type of data, that can be images or that can be video or that can be text data. But generally data has been, yes, if you talk about regression, as I said, it is something like relation, finding out the relationship between dependent and independent variables. So let's make it clear how data has been emerged and why. If you talk about statistics, it is something like how you describe your data. Something like descriptive statistics, you perform some analysis that can be of any kind. You can talk about e-commerce, or you can talk about stock data, or you can talk about any kind of data. Generally, I'll relate now statistics to machine learning, and then we'll go for how that has been termed into some kind of regression models and what are those. So basically, if you see, data is broadly categorized into two types. One is categorical and the other one is numeric. Because if you talk about the data which is categorical, that is qualitative data, something like you can say that is nominal and ordinal. When I talk about nominal, that is no numeric values are involved. Something like if I ask your blood group, what do you say? You tell that as A positive or O positive. You tell some number, right? I mean, you tell some name. You tell some category. It is not numeric. So when you talk about categorical data, that is nominal and ordinal, where you include, when you go for nominal kind of data, that is some kind of blood groups or gender. So where you don't need any kind of arithmetic operation, right? You're trying to only go for categories. How many most people are occurring? So can anyone say what is the statistical term to find out the most occurring value? If you can see can anyone say what is the statistical term to relate the most occurring common term in statistics? We name that as something. Yes, that is mode, right? So for nominal kind of calculation, we use mode operation. Then if you go for ordinal, you add some other better feature, something like you specify, say, you add some satisfaction to it. Happy, very happy, good, very good, bad. So for that, you try to divide that thing into quartiles, or you find out the average calculation. That's where mean comes into picture. So I wanted to relate how statistics is related to general terms. So that's how, if you go for categorical, I mean in categorical we have nominal and ordinal. In nominal we generally say that is no numeric, which includes something like blood group, gender. So there only you can have most number of people, that is mode. If you go for ordinal, that is you add some better feature towards it. That's how the quartiles, mean calculation comes into picture. Then if you go for numeric, as usual, you can see intervals, ratio. There you have the terms of standard deviation and how you are trying to deviate from particular interval to another particular interval. So that is how statistics has been emerged, not in 21st century. That has been something like it's purely from 18th, 17th century itself. Yes, will you agree with me at that point? Yes? Do you agree with me? It's not the newest term. It has been from the old terms, something like previous generation, 17th or 18th. Then came this terminology called as machine learning. We are using the same techniques which we are using in statistics, and we relate that thing to in a better way. That's where we use the help of Python programming, where we specifically call machine learning is the field of predictive modeling, where you try to minimize the error of the model, you try to relate that thing to your output variable. That's where the concept of dependent and independent variable has been comes, and that's how this regression classification has been related. So that is the reason we can segregate machine learning into three types: supervised, unsupervised, and reinforcement learning. So supervised, as the name itself says, that is something like where you go with the help of a trainer, something like mother guiding you. Whenever you are when you are a kid, mother will teach you how to eat, how to walk, how to learn. Mother will guide you, mother and father will guide you in every way. So that is something like supervised, which is according to task. That's how classification regression. If you go for unsupervised, you go with the data, you try to find out the patterns within the data. That's how clustering, association, reinforce, something like RFM analysis, that all comes under unsupervised. No trainer, where you try to learn from the labels. If you go for reinforcement, this is something like where you try to learn from your mistakes, where we actually do in our real life. Yes, if we are about to catch fire in our childhood, what does it happen? We get some fire burn, right? So people, we rectify it. So whenever we see fire, we stay away from it because we have already been experienced. So now let us deal based on the type of learning. We tell statistics has been emerged only with the increase of data. That's how we relate statistics to machine learning, where linear regression has been developed in the field of statistics and is studied only as the model where you try to understand the relationship between your input and output numerical variables. Yes, we'll relate. So first let me tell you the relationship, say something like cause and effect and the functional relationship, as you said. So from that, I take out my important terminology. I'll relate my simple line equation y is equal to mx, right? Where y is your dependent variable and x is your independent variable. Because I can tell that thing in machine learning terms, your labels and your features. Labels are your output, features are your input. So your input are x terms, your output is y term. Because based on this simple line equation, everything has emerged. Previously, we used to use statistical techniques. We used to use some predictive techniques. Instead of using this programming knowledge, people used to use Excel sheet and make data analysis. Then why in this 21st century people are rushing towards it? Because they cannot hold that much amount of data. They need to have some automated kind of tools. That's where machine learning comes into picture, where you try to make your data learn from the experience, right? So that's how you make your machine learning model learn from experience, and you try to find out a functional relationship where, so that in regression, whenever we try to find out a functional relationship so that you make your data more vulnerable. That means according to your input, in future you may get any kind of data, it should learn from the experience. For example, if I ask you 5 plus 6, you instantly tell 11. You need not have a second thought. If I ask you 5 plus 6 into 21 plus 35 into 15 divisible by 2, you may take some time, but you know the logic because you have already been trained with the kind of operations. So in the same way, when we go for any kind of data that can be categorical or numerical, if we are trying to work out a numerical relationship, we'll try to find out a relationship. And in that, the first model which has been gained its importance, if you're trying to find out the relationship between a linear data. What do you mean by linear data? That means you are trying to find out whenever your input, whatever some kind of features. We are today working on advertisement data set. So your features can be your, say, your marketing on TV, marketing on radio, newspaper. Your output will be how much amount you are getting on sales. That's right. That's how the forecasting, weather forecasting, all these things comes into picture, where you are trying to find out the relationship between your dependent and independent variable. So that's how I make sure This is something like easiest statistical method. So by the end of the session, you'll be able to understand how Python programming is related to advanced Python libraries, where we gonna use sklearn. I'll try to show you how in a better way we try to use linear regression. So just basically in line equation, this is a simple line equation. What does slope determine? Anyone? What does slope determine in line equation? Because my terms may look pretty simple, but those things play a very key role. What do you mean by slope in a line equation? Just a simple inclination or gradient. As I said, we'll be doing how a simple linear regression model can be framed, because we are having n number of parameters including ordinary, least square, gradient descent and all the things. I'll be using a simple technique where you can apply for any data. Yes, if you talk about slope, that is something like how steep or how to determine your data inclined to your axis. That can be x-axis or y-axis. So here y is your dependent variable, x is your independent variable, where c is your intercept. So our target is to make sure the line which we find out will be the best fit line, and it will cover the entire data. Why it should cover the entire data? Because it should learn from the entire data and it should give a better relationship. So if we have a better relationship, our lives become very happy, and in the same way our model will learn in a better way. So that's how in practical terms we'll do the same thing. We'll find out the error, that is called as from your input values and your predicted values. You try to minimize this error. For that we use some parameters called as ordinary, least squares, gradient descent, mean square errors and all these terms. Because why do you want to minimize the error? So in future you may get any kind of values, we may use our data should learn. That is the simple procedure. Then why I should go for linear regression? Because simple only, the difference between regression and classification is when you go for regression, you are trying to find out how your value is going to change. If you go for classification, you are trying to choose in which category this belongs. For regression, you may use stock prediction or advertising sales or house price prediction, how you are going to predict. If you go for classification, some kind of survival rate and age gender prediction, how we are going to categorize. Then why I should go for linear regression? Because regression is the best statistical method, and in linear, if you are having simple line equation y is equal to mx plus c, you can go for linear. If the degree increases, what you call degree of 2 in a line equation? What do you call it? General line equation is y equal to mx plus c. What happens if the degree increases? Yes, that becomes quadratic. It is quadratic actually. The parabola and all the things are the forms of the polynomial. So quadratic. In the same way, if our data is having multiple variables, we can go for multiple linear regression. Today, even though we take the multiple variables, I will try to find out which data you are going to choose. I mean, which feature is going to affect your labels, right? So that is how you confirm your data set, whether you go for applying a regression model or classification. Because as I said, from all the webinars, I am trying to convey you only the task of data scientist or a person who is working on data is about how he should collect the data and how he should make his data in a cleansed form. So here our target is to find out the relationship between the dependent variable and independent variable. So first what we'll do is we'll calculate them value, we'll find out the predicted line equation, and then we'll use our regression parameter. We have the formula for it for least squares, which is summation of x minus x bar into y minus y bar by summation of x minus x bar into, you can see the slope formula. Generally, if you see the slope formula is y2 minus y1 by x2 minus x1. If you take up 2 points, yes. So features are your input, labels are your target. Am I correct? The slope of a line is difference between 2 points, right? y2 minus y1 by x2 minus x1. Am I right? Everyone? y2 minus y1 by x2 minus x1. Yep. So then I am going to use my sum of squares of method where I go for multiple values. That's where my concept of summation of x minus x mean into y minus y mean by summation of x minus x mean whole square. Because in your y, x, you need to calculate m and c. So then you will get a regression line. For that, you need to find out the best fit line with a concept called as coefficient of determination, which is called as R square value. For that, you can go for mean square error and so many things, but I would like to make you simple how we can use the ordinary least square method and the coefficient of determination, how we can predict your target. So that's what we are going to do. So I'll share you the data set. Whatever we have seen in a theoretical way, we'll do it in the practical way. So if you see the final step, our ultimate aim is to reduce the distance between the real values and the predicted values. Why you should reduce the error? Because your model should go in an actual way, even without the help of human being. That's why machine learning is going to take place the very much importance in this 21st century. That can be application subset of machine learning, deep learning, or computer vision or natural language processing. It should be proctored by humans. It should not take the help of humans. And in the same way, it will not overcome humans. It will only enable humans to do the task in a better way. You can open your Google Colab. So I hope everyone know how to use Colab, because I may not expect that every one of you use Anaconda. So you can open your Google Colab. Yes, open Google Colab and you can type, I'll share you the data set. You can search for tinyurl.com/linearweb. There you'll be having a data set. You can download it. tinyurl.com. I'm typing it in the chat box. tinyurl.com/linearweb. Yes, you can see, you can open that URL and download the data set. Yes, I have already sent the message in the URL. You can open that data set. It is an advertisement data set where we are trying to find out the relationship between our sales and in what we have spent our money. Send that message, tinyurl.com/linearweb. The data set is advertising data set. You can directly see it. Then open Colab. Yes, that's advertising data set where we are. Yes, hope you know how to open Colab. Everyone, just click on new notebook. I hope you can see my screen, right? My Colab screen is being loading. So why do I prefer Colab? In the sense you have n number of platforms. The thing is, it is pretty much simple for anyone. Even though you don't have any kind of software for Python programming, Colab provides you, see, it provides you minimum amount of RAM. That's a pretty good amount of RAM, 12 GB plus, and it provides you good amount of storage. Colab, C-O-L-A-B. You can type it in Google. That's Colab, C-O-L-A-B. I have already sent the message. You can just type it in Google and you can, I'll rename that thing to regression. Yes, cool then. So just upload the data set. How will you upload the data set? You can see to your left side. You have upload option. You choose the file, advertising. I hope you have downloaded it. You will be having it in your downloads. You can see your right side folder option. Then click on upload option. Then the file is uploaded. Yes, I hope then we are good to go. The first step is used to import the packages directly. Now I'll relate how our basic Python libraries with the help of numerical Python and with the help of Pandas. I'll read the data set and I'll apply some mathematical techniques on that and we'll find out the regression analysis. That's our motive. So first import the packages, import Numpy as NP, because Numpy is pretty good mandatory where you are trying to read everything in the format of array and you have the formula right for ordinary least squares. You should use Numpy because there you need to calculate the mean. You don't have any mathematical operation directly giving out mean in Python programming. Even if you use math library, it has only specific kind of functionalities. So for that, I import Numpy as NP, Pandas as PD, and for visualization, I import Matplotlib. See, the advantage of Colab is you can see it will directly give you how you can load the packages. Import Matplotlib. Numpy is for numerical Python, Pandas is for reading the data set, Matplotlib is for visualization. Yep, so once your data is loaded, you just read the data set. Data is equal to, how do you read it? pd dot read underscore csv of, make sure you give the name correctly, advertising. As I gave A in the capital letter, you just read it directly. Generally, if you read from your system, you give your path, but here you are using Colab, you can directly call the file name. Then if you want to see the data in it, data dot head. So head is the top part, right? In the same way, head will give you the top 5 rows of the data. Import numpy as np. I'm renaming it. You can use any names. Numpy as np, pandas as pd. You can, once you open Colab, to your left side, you'll be having a files option. Click on that. It is similar to uploading your data to Drive. Yes. So you can see the data where I'm trying to find out the relationship between what are my input variables here. You can see that as TV, radio and sales, right? TV, radio and newspaper. So when I talk about linear regression, I need to use only one variable. I mean one dependent variable and your one independent variable. So in this, I cannot say which one, TV, radio or newspaper is it. So I'll start taking it. If you want to use all variables, then the concept of multiple linear regression comes into picture. So here, first I'll take any variable, but you can see you're having the first column as unnamed. As I said, you have 4 steps: data collection, data pre-processing, building a model, model deployment. Model deployment in the sense we are trying to host it. So we are covering all those things in this quarantine webinars. So you need to first clean the data. So you're having data.head, then you need to remove the first column. How can you remove it? You can use drop method from pandas. Data.drop off. Make sure you can copy this unnamed 0 as it is and paste, because if you write, you may miss some spaces. Make sure you copy it. Axis is equal to 0 because that is your row. I mean axis equal to 1, sorry, that is your column name. And in place is equal to true. In place equal to true. Why do I apply in place? That means unnamed column should be removed from the data set. You need to remove the first column because in place is equal to false. That means you have again, you can see if you apply in place is equal to false, you run it, unnamed, I have already dropped it, so you get an error. So what you need to do again, you need to rerun it again. You need to use this. See, it is fine here, but here when you go for data.head, what you can experience again, unnamed column is present. So that is the reason I use in place is equal to true. So once you drop it, you need not drop it again and again. Make sure you directly do once. That is the reason I'm using in place is equal to true, so that it is applied on the entire data set and that column will not repeat again. You can directly open Anaconda and read with the help of pd.read_csv. You can directly give the file name. Now you can see data.head. You can have the data with the column unnamed removed. Now let's perform some data cleansing operation. Data.isNull.sum, because I always suggest people whatever data set you may take, you check out whether the values are present or not. So your data set is clean, your independent variables are same. So your data set is clean. Yes. Can I proceed for the next step? You need to take out your dependent and independent variables. Then you go for collecting your data. Collecting X and Y. So I give X is equal to data of, I take my first column TV and I need to take the values from it. X is equal to data dot values, because X is your independent variable, y is your dependent variable, because I need to find out in the format of line equation y is equal to mx. You check out with the thing you need, what is the error you are getting. pd dot read underscore csv, once you read it, you can drop unnamed, your column name, axis equal to 1, in place equal to true. You hope you try to understand from the beginning itself. Once you missed it, you'll be facing some issues. Please try to understand from the beginning. So once you have set out in your x, then you go for y. Y is equal to, what is your target? Sales. Your Colab will give you suggestion what are the values present over there. Sales dot values, because you need to take the values in the format of an array. That is the reason I'm giving values. If you click X, you get all the values in the format of an array. Why should I give in the format of an array? Because you are trying to build a Python program. In Python, if you're going to give multi-dimensional input, you need to read it in the format of an array. Int 64, that is an integer type. D type is integer type. Your input is done, then you should calculate your M, your C, and then you need to find out the coefficient of determination. Yes, is it clear till here? Then if it is, then I'll calculate mean. So as I said, the formula for mean is, that is ordinary of least squares, that is sum of squares, summation of x minus x bar into y minus y bar by summation of x minus x mean whole square. X minus x mean, y minus y mean by x minus x mean whole square. Yep, so let's find out. Dot values will make you that in the format of an array. You can check it out by your own, because if you directly take x of data of TV, you don't get that in the format of an array. Now I'm using only pure Python libraries, calculating the coefficients of mean of x and mean of y. So if you want to take mean, you can use only Numpy, because in math module you don't have mean. So let me finish this and let's see the queries. Mean of x, np dot, I need to calculate the mean of my x values. Make sure you give the case sensitive values. Print of, if you want to take mean, you only have the option from np.mean. That is the reason I'm using Numpy library. Mean of y is equal to np.mean of y. Then you print both the values, mean of x and mean of y. For your sake, I can copy this thing and place in the chat box if you are having any issues. Yes, you need to calculate mean of x and mean of y. We have removed the unnamed column, that's it. Statistics model is not needed because we can directly use mean from Numpy. If you go for SciPy scientific Python, you can directly go for regression analysis. Here I'm using only basic Python library so that any person from any background can easily understand. I am relating statistics to Python. That's how you calculate the mean. Mean of x, mean of y, which forms the basis for calculating of OLS, ordinary least square method. As the formula is summation of x minus x bar, summation of x minus x mean into y minus y mean by summation of x minus x mean whole square. Because you are trying to find out because that is open, you can check it out. Everyone is having, you should make sure you should log in through your Gmail to access Colab. Please check it out. Someone is asking the error. So to find out the ordinary least square method, ordinary least squares. So if I would like to have a numerator and denominator, then I should know the length of the values, right? Numerator by denominator. Summation of x minus x mean into y minus y mean by summation of x minus x mean whole square, right? Then I need to first calculate my length. Hope if you have some Python background, length always returns the number of items. I'll take length of x because x is your input. You cannot take the output. So length of x. Now I use the formula to calculate b1 and b0. That means that is y is equal to mx plus c. Something like b1x plus b0. You can take that as anything, whether you can take y is equal to mx plus c or anything. b1 and b0. So I need to define in the format of numerator and denominator. If I want to access the number of values, what should I do in Python? I should go for control statement, where you need to go for, because you are having 230 plus values in the data set, you cannot calculate one by one value, right? You depend on control statements. I mean loops. You need to write a loop over here. So you define the variables as numerator and denominator. You can name any of them. So it should calculate each and every value of x, each and every value of y, and we should get m value. I mean m in the sense here b1, c in the sense b0. Just for nomenclature purpose I have taken. So now I define for I in range of n, because I need to know the length of the values. I define my assignment operator over Python. It should increment because it should end at the last value. Summation of x of I, that is x minus x mean, into, because I should take individual value, right? Each and every value should be taken. That is the reason I am taking x minus x mean into y minus y mean. By denominator, why I am using plus is equal to, that means numerator is equal to numerator plus. Each and every value should be added to the next value. That is the meaning of control statement, right? You iterate every value. So the denominator is xi minus mean of x whole square, that is power of 2. So if you want to get the b value, I mean if you want to get the numerator, that is b1, b1 is equal to numerator by denominator, because b1 is your slope. And how you find out c value? C is equal to y minus mx, right? b0 is equal to, what is y? Mean of y minus what is mx? b1 into x in the sense mean of x. That is the reason I am using Numpy. Numpy plays a very key role in Python only. That is not something like an advanced library. It is a library if you are trying to use for statistical purposes. You get the b1 value, slope in the format of 0.04, b0 in the value of 7.03. I have calculated my m value and c value. Then my next step is to see the line equation. If time permits, I will show the same thing in Scikit-learn, where the steps will be of just 5 lines. The linear model is, I write in some way, y is equal to, I use my Python format statements to hold the values in decimal. Y is equal to mx plus c, right? So I am defining slicing operator to hold out the round of values. You just go with the same mathematical term, dot format. Dot format will replace the values, right? b0 comma b1. See, now you get the line equation. Whatever the values you have find out from the above line, you can get them. Yes, you can. I have already pasted in the chat box. You can go ahead. So that is how you get the line equation. I am pasting only in the chat box so that everyone can follow the concept. Now our half task is done, finding out the m value and c value. Then you need to find out the predicted values, right? So for predicted values, you need to see how you can show the graph first. Now I need to plot a graph for my input values and my line equation values. That's what we have shown here. That is your regression line. Regression line will pass through the slope m. So for that, this entire step is for plotting values and your regression line. Regression line will not be the best fit line every time. So to make it as best fit line, we go for calculation of coefficient of determination. That is generally called as performance measure or cost function in machine learning. So this step is for plotting out the values and regression line. So I have capital X and capital Y as my input. Now I need to have some other thing called as small x and small y to plot the graph, because for input I gave capital X and capital Y. For regression line, I'll take some maximum values so that I could get the graph in a better way. This is only for visualization. np dot max of capital X plus 100. You can take anything, plus 100 or plus 1000. That depends on your interest. This is only for visualization. To visualize the regression line, I am taking maximum values. np dot max will give you the maximum out of maximum value from the x column. maximum of x and minimum of x. This print statement is a line equation. Y is equal to mx plus c. Their colon is slicing operator, right? If you increase this to 3 digits, you can see how does that change. Only 3 decimals. 0.5 in the sense 5 decimals. Dot format is the print type. If you go for maximum and minimum, now I'll calculate my line values. Calculating line values where you use x is equal to np dot. I use linspace. Why do you use linspace? To hold out the values within your interval. What is my minimum interval? Minimum of x. What is your maximum interval? Maximum of x. I define those values in the format of 1000. And what is your y? Your y is your line equation. mx plus c, b1x plus b0. Make sure when you write multiplication b1 into x, because x can be considered as your input. X is your input number of values, because you are taking some maximum value so that you can observe that in a graph in a pretty good way. Now I am plotting my line. So just plt dot plot of capital X and capital Y are your input, and if you want the color as red color, and the label here it is regression line. So this is for small x and small y, because capital X and capital Y you get a scatter plot, because you're having n number of values, right? Regression line. Regression line is nothing but the line formed with your line equation y is equal to mx plus c. plt dot scatter of capital X comma capital Y. Make sure you define the variables in a correct way. Color c is equal to blue. Make sure you write the terms in a correct way. And label, because this is where you go for visualization with the help of Matplotlib. Scatter plot, and you go for plt dot x label, that is money spent on TV ads. Labels is nothing but whatever the values you can get on the axis. This is for sales, and I use my legend function. If you are following our previous webinars, you would have known what are these things. Legend is for locating the labels, and you see the graph plt dot. If you are good at everything, then you'll get this graph. The straight line indicates your regression, and the dots indicates your scatter points. Server has been interrupted means make sure you are having good net connection, because Colab will only need your internet connection. If you are using mobile phones or hotspot, please try to make sure. Yes, you can see the graph where I have been plotted with the help of x plus 100 and plus minus 100, your minimum values, 400 and minus 100. If you change plus 1000, this to 1000 and minus 1000, you can see the axis graph. See, that is minus 1000 to plus 1000. You cannot see the dots clearly. So that is the reason I am giving out the pretty good values with the best values. Minimum plus 100 minus 100. You can see your scatter points, and your straight line is your regression line, which is formed with the help of y is equal to mx plus c. This is only for visualization. Now we need to find out the coefficient of determination in order to make my best fit line as the regression line. You can see all these scatter points, right? These scatter points will make your input data, and you can see that as linear, because if this is not linear data, you would have not get a straight line. You would get a polynomial. That is the reason I'm using linear regression for this kind of data. Location is equal to best. Location is equal to best in the sense you need to get the label, this tabular format, in a best place. You can make some mistake in that, it will give you the suggestion. My next step is to find out the how close these scatter points are fitted to the regression line. Then I can see, I'll find out the R2 score, which is nothing but a statistical measure. It determines how well the data is being fitted. The range is 0 to 1. The formula for it is 1 minus summation of a y minus y mean by y minus y predicted whole square. Summation of y minus y mean whole square by y minus y predicted whole square, that is 1 minus sum of squares of errors by total variation. For that we calculate. So scatter plot will give your input data, and you can see the scatter. plt dot scatter is for your input data x and y. X is your TV, y is your sales. This y is your line equation, x is your input values with the help of maximum and minimum. This is not yet done. We are showing, okay, this is a linear regression curve. That's it I'm showing. In the next step, we'll find out the statistical measure. That value should be greater than 0.5 because that lies between 0 to 1. You should import Matplotlib. Import matplotlib.pyplot as PLT. You try to debug. That is only the best way. Yes. So the next step is I need to find out my R square value. So my R square value can be found out only with the help of predicted values. How I can find out the predicted value? That means the new values, you substitute your line equation values. That is B0 plus B1 into I. You can directly use this in line equation or you can find out any value, because if you find out some x of 2, you can get the predicted values for it. Why predicted for x of 2? That is the third cell, because you can see what is your x of 2, this is your value. That means you can see from the tabular data x of 2 in the sense this is 17.2 is the TV money spent, and something like it may be in dollars. You should get around 9.3. How much we are getting? We are getting around 7.85 because we are using only one factor. We are having some other factors. Now I'll consider how we can calculate our R2 score. It may take just 5 more minutes calculating this R2 score. So by this I can say this is the performance measure, how well I can relate, because I may not get exactly 9.3 because this is only prediction. We are trying to relate our predicted data to the input data. So what I do here, I go for again numerator denominator. I go for some naming some variables with the help of total variation as 0. This is just some dummy names. You can give out any names because the formula for R square is summation of y minus y mean whole square by y minus y predicted whole square. So for that formula you can give same for in, I define range of n because n is the length of x, and you take individual value. Individual value is b0 plus b1 into x of I. I stands for taking individual value. Then what is the formula for the numerator? You should increment it same as in the above case, that is for calculating the least square by calculating m and c. This is for calculating the R2 score. yi minus, see here I am using only pure Python libraries and pure Python functionalities. I am not using anything other than that. Y of I minus y underscore prediction, because that's where you calculate the R2 score. So finally you can get R2 score is equal to, it's not numerator by denominator, 1 minus, because you need to restrict the values between 0 and 1. If it is negative, that means your model is not trying to learn in a proper way. That should not be negative anytime. If it is negative, that means your prediction is going wrong. Print R2 score and I print the value. It should be greater than 0.5. If it is greater than 0.5, our model is able to learn. It's pretty good. You are getting 60% R square. The logic in the loop is simple. You are trying to iterate each and every value. That is simple Python logic. Y predicted is equal to y is equal to mx plus c, and this is your numerator, because I cannot give again numerator because already above it is defined with the help of numerator in the above cell. You can point it out here. Same logic I'm using here, but I'm taking the predicted values of individual x with the calculation of m and c. This is how you can calculate your linear regression with the help of Python. So how can I convince that only 60% I'm getting? Because 60% your value is about to match. That is some name. You can give out any name. Any name you can give. TOT or RES. That is some name. R square is 1 minus summation of explained variation by total variation. How your data is going to change. These are variable names. You can give out anything. R square is a statistical measure to find out how close the data you are fitting to the regression line. How close the statistical points are able to fit. Yes, you should get that thing above 50%. That means your model is able to learn. Now, this is purely about Python. Here I have used only simple things and I have calculated the how the model is able to perform. Yes, every formula is about in the PPT. It's not about accuracy. We don't call this term as accuracy in regression. We call it as performance measure or cost function, which is coefficient of determination or coefficient of multiple determination. It is how well your data is fitting. I have done for TV. You can practice that for newspaper and you can practice that for radio, because what is my prediction value? I have predicted already here. You can see I have taken my third cell value and I got the output as $7.85 million. That is my predicted value. But what is my input value? It is 9.3. Because I got 60% of more weightage to TV, I can say this is the best feature I can use for prediction. You can try for newspaper and you can try for radio. You will get for sure very less value than this. This regression line, we are using the formula. We have the help of line equation. We have calculated M value and C value. When you calculated your line equation, you give out some your own predicted values. How you can do with that? This is the line for predicted values. Predicted. We are substituting your B0 and B1. You can see, you can have B0 and B1 values from the above cell. What are B0 and B1? You can refer this 17th cell, B1 and 18th cell, and in that you have the values. You are calculating for each and every input, x of 1, x of 2, x of 3. Then you get the statistical measure of R square. Y minus each y minus summation of y minus y predicted whole square by summation of y minus y mean whole square, restricting with interval of 0 to 1. That is 0 to 100%. If you are getting above then if you are getting above than 50%, then you can see that your model is able to learn in a perfect way. This is purely by using Python. That is how statistics is related to programming. Even R programming can also be used, but in a simple way I have used only my Numpy, Pandas and Matplotlib for visualization. You can see by this graph itself you can conclude, okay, my data is able to match in a linear way. You can plot the same graph for taking out newspaper and sales, just replacing X value here. I have taken data of TV, you can take data of newspaper, data of radio, then you'll understand. This is by using purely Python. If we use Scikit-learn, you can write anything. You just R2. R square is nothing but that is the name of it, coefficient of determination or coefficient of multiple determination, because you'll be taking out from the sum of squares of errors according to your input. That is the reason the name itself is R square. Yes, this is by using pure Python. If you use Scikit-learn, that step will be reduced to just 5 values, where you take the data, fit the model, predict the values and find out the score. So this is how Python is related to statistics. Is it done? See, the formula, the name itself is coefficient of determination or R squared value or R2 value. It is not that finding out the squares. So that is how we relate Python to statistical programming. So 60%, if you are getting 1, that is pretty wrong thing. You should get around 60%. You will not get any time 1. Probably you might have not adding the values here. You should get around 60%. How many of you got the output? In Scikit-learn, that will be 5 steps only. That I would not want to tell, because you need to understand the core functionality of the logic, how we are trying to use Python. Yes, I hope you understood. So you need to make sure that how we are using linking your Python to Python programming to statistics, and that statistics to machine learning. So in machine learning, we can directly use, we need not calculate this mean and everything. We directly call from Scikit-learn linear model, import linear regression. You fit the data, you predict it, you calculate the score. That's it. That is the reason machine learning is helpful for enormous amount of data. So more than 90, then that is based on your input, then that is pretty good, fine. Yes, if you are interested, then within 5 minutes we can wind up with Scikit-learn. How many of you are interested to do it? Within 5 minutes we can wind it up. After finding score, that is, you can see that is 60%. So you can see how that is, how we are trying to find a relationship. Yes, so as per the request, we'll go for it. We'll just import Scikit-learn and I'll show you the difference. Within 5 minutes we'll wind off. Only due to the participant's request, you'll get the score in the same way. Yes. Okay, then I need your 10 minutes of time. Then just you can go for from sklearn.model import linear regression. Simple, because you need not calculate M, you need not calculate C, everything you need not calculate. You can just embed this model from linear regression. Everything has been framed. See, you're getting, sorry, from sklearn.linear_model. That's my typo mistake. Because it's a linear model, you can directly take it. Within just 5 minutes, we can finish off that thing. You take your input, same x is equal to, but you need to reshape here. X is equal to data of PV, because sklearn will always take the data in multi-dimension, not a single dimension. So for that, I need to reshape that in -1, 1. Because you don't know the shape of it, you can directly give it out. Data of sales dot values dot reshape, because sklearn will always take the data in the format of multi-dimension. You just take out this. If you want, I can place this in chat box. In just 5 minutes, we can finish off that thing. Because you need to understand why Python is important, why Python is related to statistics, and how machine learning has been emerged. You initialize the model. What is your model name? Linear regression. You take up the all functionalities. So you need not define anything here. You can directly give out reg.fit method. Because in this we can have much more things. See, copy, intercept value is bin fitting, n jobs is equal to none. This is used in classification. If you follow our next webinars, you will understand. Reshape is nothing but we are trying to reshape this single array into multi-dimension. Because you don't know the shape, sklearn provides you the flexibility. You can use reshape of -1, 1 to make any array of any shape. The data is fitted, then directly you can go for prediction is equal to reg.predict of x directly. Because machine learning, you take up the data, fit the data and predict the data. But in the middle steps, you have the terms called as feature scaling, hypertuning. We have all the things. So finally, if I want to calculate the score, I can go for reg.score. That's it. Because reg is your model, score is your input. You give out your terms. So if I want to print score, R2 score, you take up the value, you should get the same value. See, you got 61% and 61%. As I said, 5 steps are done. You can relate the same thing. You take up the data, fit the data to model, you go for predictions. You are calling up your model because you need not calculate M value, C value. You need not calculate that thing with the help of calling up the mean, you calling up the equation. You need not do anything. You can directly give out because we are having all the functionalities with linear regression. That is the advantage of statistics relating with machine learning. See, only 5 steps, you can fit the data, you can predict, and you can see the score automatically. See, this is how we teach machine learning and data science in Codegnan. We relate everything to statistical models and we see everything so that a person from any background can easily understand. You can relate the score over here, you are getting same thing. The same score which we got, because you can try it out for newspaper and sales, newspaper and radio. You can relate how your dependent variable is changing for independent variable. Yes. So that is the advantage of sklearn. That is the reason sklearn is the heart of machine learning libraries. Simple Python with the help of mean and everything. I have reduced that thing into just 5 lines of code. If everything remains same and you call the model, in fitting you go for selection operators, that is called as feature selection or model selection. Then you go for predict, you give out the value, and you predict the values. Hope did you relate the difference from linear regression using Python to sklearn? Yes? Right. So this is how we teach everything. I teach in a way with something like you try to represent that thing to statistical model and you represent that thing. You should call the model REG. REG is linear regression. Yes? Nice then. Hope you have understood the session. We'll be sending the materials and certificates and the recording by the end of the day. We'll also be sending the links for the next webinars. Hope you make use of them. Thank you. Thank you for your feedback. Hope you liked it. Please make sure that this is the way we teach and you try to understand how we are relating mathematics to data science.